Okay, constructing graphs, exercise 1.06. So when displaying a set of data, remember that you must select the appropriate type of graph or display. So we do not use, there are only certain things that line graphs are used for, only certain things that column or bar graphs are used for, and only certain things that sector graphs or divided bar graphs should be used for. Now, column or a bar graph, so column graphs are the ones that go up and bar go sideways. They're good for either categorical or quantitative data, but that will be discrete quantitative data. Okay, they show differences in amounts. You'll see the differences in the heights of the columns. What's good about it? It shows exact values. You can put a large amount of data there in it, but they do take a long time to draw. Now the important, so either categorical or quantitative, I put quantitative discrete data. Data that can be counted, not continuous data. You wouldn't do temperature in a column or bar graph. You're going to see examples of what we do very soon, okay? Now, line graphs are for continuous quantitative data. Like the temperature, just think of the things you might see line graphs for. You know, line graphs look like this, whatever, okay? It might show temperature over time. It might show distance travelled over time. So things that can be measured over a time period. So line graphs show changes over a time period. Okay, so again, they can show exact values. You can graph a large amount of data. They show differences and patterns quite clearly. You can see if something's increasing quickly or decreasing, or if it's staying roughly the same. And it can be used. So when you do, like you might have some points or something, and you might be able to estimate a value between points. Okay, and the thing about line graphs, and this is really important, that you can only use it to graph continuous data. So continuous is numerical, but continuous data is stuff is data like mass, like temperature, like length, measuring something on a ruler. All right. And sector graphs or divided bar graphs, please just use those only for categorical data. So, you know, type of music preferred by students, type of food in the canteen, colour of eyes, okay? So sector graph or divided bar graph. Now we're practicing those today, sector graph and divided bar graph. They show parts of a whole, that's their strength, but they don't show exact values. And if you've really got very small proportions, like let's say you've only got 1% of students that chose something, it's not very good for showing that, because the sector would be really, really small on the graph. So your sector graph, remember, looks like this, where you've got your different sectors, all right? And your divided bar graph looks like this, you know, that sort of thing, divided bar graph. But if you did have a very small section, like a very small amount, you wouldn't be able to show it very well. And sometimes they'll put a whole group of things together and they'll call it other, okay, in a sector graph or in a divided bar graph if there's not much room to show it. The main things you want to take from here are that a sector graph or a divided bar graph are for categorical data, categories, not numbers. A line graph has to be continuous, quantitative, which is numerical data, things that can be measured, and column or bar graphs can be used for categorical or quantitative, but discrete quantitative numbers, like how many mobile phones are in the house. That would be an example of something you could put in the column graph. How many siblings do you have? All right, so that could be in a column graph. So a column graph, you know, we know looks like this with all the different columns, okay, and numbers down the bottom. All right, we're going to be drawing those. We'll actually draw some frequency distribution tables anyway as well. So we've got the line graph there, the sector graph looks like this, the divided bar graph looks like that, column graph looks like that, and the bar graph is just the sideways column The sideways, actually columns should have gaps between them. Column graphs have gaps, but frequency histogram and polygons don't. So I'm going to get rid of that column. Column graphs have gaps between them. They should be evenly spaced apart. Okay. Oh, I probably should have put a 0 column there as well. Sorry. And bar graphs are just like a sideways column graph. Okay. Okay, looking at some questions now. Question 2. Georgie won $800,000 on a quiz show and spent it as shown in the table on the right. So we would hope that that would add up to $800,000. It says, why is a sector graph or divided bar graph suitable for this information? Why? What sort of, I know we've got numbers here, but what sort of data is this? The money's been put into categories. So it's because the data is categorical data. Because when we graph this, if we use our sector graph, we can write in the different sectors. This was for home loan, that a section was for the car loan, etc. Or if we did a divided bar graph like that, we'd have the bits in different sections like travel, savings, etc. So it's categorical data. That's why a sector or divided bar graph is suitable. They want us to draw a sector graph. All right, let's work out how we're going to draw it. We need our angles. So it did say that the total was 800,000. Has anyone checked that? Added all of those up and make sure that they add up to 800,000. When you're adding these up, if you want to check that they add up to 800,000, because we've got 3 zeros on all the ends of these, I'd just be going 235 plus 96 plus 144 plus 125 plus 200 and make sure that you get 800. Don't go and put all these zeros in, otherwise you're going to start making mistakes. Okay, so the 800,000 is correct. So the sector graph, so let's look at the home loan. How much is the home loan? It's 235,000 over 800,000. That's the fraction that is for the home loan. Now, you know what I'm going to do? I'm going to cross off the 3 zeros from the numerator and the denominator. And from now on, when we work out all of the sector angles, let's just put the amount without the thousands. You'll still get the same answer. Now, that needs to be represented in a sector graph. How many degrees in a sector graph? So that's the fraction that's home loan, but it has to be represented out of 360. So we'd say that's the fraction I've got and I times it by 360. I mean, if you look at 800,000, tell me what half of 800,000 is. 400, what's half of that? What's a quarter of 800? 200. See this answer, 235,000, this section? It's got to be more than a quarter of the graph. Does that make sense? See, when you see that 800,000, you should automatically think, right, 400,000 would be half of it, 200,000 would be a quarter of it. I've got 235,000. I've got to get more than a quarter. Now, a quarter is 25%. I'm expecting maybe 27, 28, 29%, 30% maybe at the most. So we go 235. You can put the 0, 0, 0, but they are going to cancel with the zeros on the denominator. So just 235 over 800 times 360. Sorry, when I was talking about those values, I was talking about percentage, but we're doing actual quantity. So we've got more than a quarter is going on to the home loan. A quarter is 90 degrees. Yeah. So we've got 105. Now I'm just going to keep it like that. I'm not rounding off. 105.75 because I think we're probably going to round this one up to 106 degrees, but we're going to wait till the end. All right. The next one is the new car. So new car, I'm just going to put 96. I mean, you can put the zeros, but notice that, just be careful, the 3 zeros from the numerator will cancel with the 3 from the denominator. So really you could just do 96 over 800 because the chances of incorrectly inputting the zeros are pretty high if you're not careful. So what have we got? Well, it's got to be, it's less than a quarter, isn't it? Yeah, it's a lot less than a quarter. 43 point. Yeah, I think this one will definitely round down to 43. The other one will more than likely be 106, but we'll just leave it for a minute. Home renovation is 144,000. Actually, I'm going to round that other one up. It should be fine. 106 degrees. Out of 800,000, you don't need to put these zeros in, times 360. You can round this one up to 65. So far we've rounded 2 up, 1 down. Travel. And you can just keep going. And savings. You should be able to tell me exactly what the savings one is without even calculating it. Yeah, good. So if we look at savings, it's 200 out of 800. That's a quarter. That will be 90 degrees. Okay. And the travel will be less, probably 50 something degrees. Travel is 56.25, rounded down 56 degrees. We've rounded 2 down, 2 up. It should be fine. You can just check the last digit. 6 and 3 is 9. 9 and 11 is 20. It should be fine. You get it? You'll have a 0 on the end. Or just add them all up and you should get a total of 360 degrees. You should always do that, add them all up. That will, that's like a check as to whether you made a mistake or not. What did Georgie do with 1/4 of her savings? We've already seen that one. What did she do with 1/4 of her savings? I mean, 1/4 of her winnings, sorry. So 1/4 of the winnings went to, sorry, where did 1/4 of the money go to? We already spoke about this. Yeah, it went to savings because, I mean, we could do this a couple of ways. We could say that the savings were 90 degrees out of 360. So there's 2 ways of looking at that. 90 out of 360 is 1/4. Or we could have said 1/4 of 800,000 is 200,000. That's how we would know that 1/4 of the money went to savings. But remember when we first looked at that data, that's something that we should be thinking of. Half of it's this much, 1/4 of it's that much. Gives you ideas as to whether you know, you're doing things correctly or not. Okay. D, what fraction of Geordie's winnings was spent on home renovations? So home renovations, you know, we've got all this information up here. What fraction is on home renovations? Can you see it? That's the fraction. 144,000 over 800,000. So the fraction on home renos are 144,000 over 800,000. Just be careful here. I'd be crossing off the zeros manually. You don't want to be putting the wrong number of zeros in your calculator in an exam. And now you can go 144 fraction 800 on your calculator and it will simplify it for you. Be very careful when if you want your answer to come out as a fraction, you must use the fraction button. 144 fraction 800. If you use the divide button, you will get a decimal answer. Okay? So if you go 144, the ABC button, if you've got the old calc, 800, you will get a fraction answer. But if you go 144, press the division symbol, divide 800, you'll get a decimal answer and you'll need to change it. Please just, mistakes that people might make, they might give the decimal rather than the fraction and they'll lose a mark. All right. And the last one, part E, what percentage of Georgie's winnings were spent on a new car? Well, whenever you do percentages, you need the fraction first. So let's do the fraction that was spent on the new car. So it's 96,000 out of the 800,000. Again, and to calculate that as a percentage, percentages are out of 100. So you'll be timesing that by 100. Now, I would cross off the 3 zeros from the numerator and the denominator so that you don't have an input error. So just do 96 over 800 times 100%. So just looking there, 80 out of 800 would have been 10%. So as long as the answer is a bit bigger than that, we get 12%. Remembering here that you don't put the percentage button into your calculator, that's why you're able to write it again down the bottom. All these angles here, I would probably start with the 90-degree one. That would be the easiest one to do, the savings at 90 degrees. You really need to locate the center of this circle. Circle, the best one to do first would be the 90-degree one, which is a quarter. So, okay, draw your 90-degree, and we might just do one other. And then, of course, you would label your section. So I'm just going to put a right angle there for that one. Savings, I'm just going to do one more. I'll just do them backwards, 56 degrees. Just making sure that you're starting at 0. Now, if you look here, I'm not starting at 0. I'm on the outside scale. So either you want to maybe start doing it over this way. That way you are starting at 0. Do you get what I'm saying? And it's actually all upside down as well. Actually, I'll come back down here, sorry, and turn it the right way. Making sure also that in the center you're not at the bottom like that. It's got to be at this cross here. And that goes on the center of the circle. So making sure you're starting it, it's good to have the 0 on the outer one. So 56 would be, there's 55. Another little dash after that. Not even sure if I got that right. Looks okay. And then you would just continue after that. Okay, so this one is 56 degrees, that one's travel. Okay? All right, you can put the angle in there if you want, but you don't have to. And then you would just continue, so savings and travel done, etc. So you would just keep going and finish that graph off. Okay? Now for question 6, drawing a divided bar graph. During a 2-week period, Australian Customs recorded the number of immigrants arriving at Sydney Airport as shown in the table. So UK 20, New Zealand 35, etc. down to other regions 6. Draw a divided bar graph. So before you can draw a divided bar graph, let's work out the total people that arrived. So you're going to need to add these all up. So you've got 55. We've got 93 people. So the UK, United Kingdom, is 20 out of 93. That's the fraction that are United Kingdom. But because I'm representing it in a divided bar graph, I need to see how long this graph is. So if it was a sector graph, I'd times it by 360. It's not a sector graph. If it was a percentage, I'd times it by 100. It's a divided bar graph, so I'm going to be timesing it by, I was hoping that was 15, but it's 15.1. Again, change size as I photocopied it. 15.1 is the length of the graph. So that's the fraction that our UK, times it by 15.1 centimetres. And we'll do that for the others. New Zealand, 35 over 93 times 15.1 centimetres, etc. So keep going with all of those, work them all out. Can I just have an answer for the first one, for the first two actually? Oh, it's 95. 1.1. 1.62 will be 1.6. 0.48 we'll do it as 0.5. 1.94. I'll just leave that for a minute. Probably 1.9. Okay. 0.97 we can do it as 1. 1.0. Okay, why don't you add up what you've got so far? Remember, we're trying to total 15.1. Or you could tell by just 7, 8, 14. 14 ends in 8. This one's got to go up. 3.3, I think. I know it's a bit, because it was 3.247 anyway. I think you need a 3 on the end to get the 1 here. So we've got 3, 10, 11, 17, 22, 31. Yeah. So that top one, round like that. So I'll just start drawing that. So UK is 3.3 and New Zealand is 5.7. So we just, to make sure it's, so 3.3. The next one is 5.7. Do you get what I'm doing now? Yeah. So UK is 3.3. New Zealand is 5.7. Yeah, I've rounded. I did round these first. I did those first. Look, I could have, I'm not sure what the other decimals here were, but I decided to round this one up to about 3.3 because it was 3.247. I know it's 15.1 if I round that one up. I did this one last. So either one of these two that I've underlined should be rounded up instead of down, whichever one's closer to, so that I can fit the 15.1. I know that's weird. All right, because if I put 3.2, I'll add up to 15. I've got to make one of these bigger. Like I've rounded this up, I've rounded this one down. This one was down, this one was up, this one was up. I did this one down. So 1, 2, 3, 1, 2, 3. Yes, so you might have to, I know this one's meant to be rounded down, but actually if I just do this one as 3.25 and this is 1.95, I'll be fine. Do you know what I mean? Do you get what I'm saying? I just make them both, that will be fine. So I'm going to go halfway between 3.2 and 3, halfway between 1.9 and 2. So I'll fix that up here. So 3.25, I've probably already, it's really hard to draw to that accuracy anyway. And then 5.7, like I said, it's really hard to make it that accurate anyway. Wait a sec, so that's UK, that's New Zealand, etc. And you would just continue. So Middle East is 1.1, India is 1.6, I'm just going to add the 1.6 onto there. Africa is 0.5. Asia is 1.95, about there. And the other is 1, which looks fine. So you can just draw them all up. And label them. Okay. Question 7. This table shows the number of motor vehicles and home thefts in the Shoalhaven area over 5 years, so from 2002 to 2006. Let's just look for the largest value on this graph because we need to plot. It's 467 and the smallest value is 312. Scale needs to, actually the highest value is 517. So a scale, we'll try and get the largest scale possible. So if we make that 50, 100, 200, 300, 400, 500, that would be 550 up there, so that would be fine. So we've got 100, 200, 300, 400, 500. Remember our largest value is 517, so in between here we've got 50, 150, etc., 250, 350, 450, and this will take us up to 550, so that's a good scale. Remembering to label our axes, the number of, I'm just going to put thefts, because we've got two different types of thefts here that we want to plot. We've got motor vehicle theft and home theft, so we'll have to do a, represent them maybe in different colours or with different types of lines, okay? And then we can just put the years down the bottom on the horizontal axis. So for motor vehicle thefts, we've got 419. So if that's 400, that would be 425. That's 450. So 419 would be about 4/5 of the way from there to there. So it'd be about there. Then we've got 381 for 2003. So that's 350, that would be 375, 381, just about 1/5 of the way up there, like 1 millimetre up, if that is 5 millimetres. 379, just slightly, well, almost level with that 381, 379, just a tiny fraction lower.
369, oh sorry, that should be here. Just ignore that one. 369, if this is 350, that's 375. 369 would be a bit lower there. And 312, this is 300, that's 325. 312 would be about halfway. So just joining those up. Oops, sorry, just not very well drawn, that first one. And labeling that one as motor vehicle thefts, or you can just do it over here, motor vehicle thefts, and then we can do home thefts in another colour. So home thefts, we've got 517. Sorry, I even put this here, is drawn in the wrong spot, so I just don't have that liquid paper tape. So just ignoring that first line there. Home thefts, 517, so we've got 500, 525, 517 about here. Oh, I didn't see that 567. I'm really sorry about that. There's a 567, which I missed. So 567 for 2003, if that's, I'm just going to add another row to the grid, okay? This is, so 2003, 500, 550, that would be 575, 567 would be about, probably about 3/5 of the way up there. Then we've got 467, 450, 475, 467, about, because you're going up 17 out of the possible 25, so a bit over halfway. 449 would be just, or put it just almost on 450, just very slightly below. And well, I think I haven't counted correctly there, a bit disastrous. And 397 would be just below the 400. Looks like I haven't counted my scale very well here. I've done 3 instead of 4, sorry. So that's 2005, 2006 should be there. Okay, so anyway, won't worry about it. But this should be 1 across, and so should this. That should be 1 across. Just crossing out those others. Okay, and just joining up now. Sorry, I should have just done that a bit better. I'm sure you get the idea. Okay. All right, and the other one will have to change as well. Need to move this 1 across. Of course, you would do it in pencil first, and then, so that you don't make the same error I made. Okay. All right, so just different colours for those, and the blue one is home theft. Okay. Sure you'll do a better job than me. Okay. But just the main thing you need to focus on here, make sure you label. Also, it's just counting up here. If that's 400 and that's 450, this is 425. If these are 1 millimetre apart, say, then every 1 millimetre, and they are almost, or they're about, it's about 4 millimetres from there to there. So each millimetre would be about 12.5. Okay, so just, sorry, no, it wouldn't be 12. Each millimetre would be about 6, a reading of 6, because you've got 4 millimetres from 400 to 425. 25 divided by 4 is 6.25, so each millimetre up would be approximately 6, okay? So just trying to get that scale, just making sure you're plotting correctly on the vertical, and of course, again, on the horizontal, make sure you don't make that same mistake that I made. And just answering these other questions, in which year was home theft the highest? Now, these are fairly easy. You'll be able to do those. 567. In which year was motor vehicle theft the lowest? Oh, sorry, it was in which year? So that's not the answer. The year is, make sure you read the question correctly, 2003. In which year was motor vehicle theft the lowest? Well, it was the lowest here. Okay, so that year is 2006. In which year? Good idea to underline keywords when you're answering your question, okay? Otherwise you'll make the same mistake that I just did. Which type of theft is generally more common? Just looking at these values, I mean, you can see it from your graph. The home theft values are higher, okay? So, I mean, you can sort of see it there as well, but the home theft, the graph gives a really good indication of that. And write a sentence to describe what happened to the number of home thefts over the 5 years. Well, I would look at the graph. It spiked from 2002 to 2003, but then it sharply declined, and then on a steady decline after that. Okay, so you could put it increased from 2002 to 2003, then declined. I'd put sharply from 2003 to 2004, then decreased after that from 2004 to 2006. Okay, and what do you think happened to motor vehicle theft in 2007? So let's have a look. 419, 381, 379, 369, 312. It more than likely declined. Okay, and if you look at the graph as well, there are no increases. It looks like it's just declining. So it declined. The graph and table show a decline from 2002 to 2006. Okay, so it probably followed that trend.